get through. And then, assuming we have some time at the end, I always try to, at the end of the quarter, make sure that we have a little bit of work time to catch up on things. And those of us that are all caught up and don't have anything to do, I put on a cool Netflix documentary or something like that. Normally made by the BBC, because the BBC is awesome. Giant welcome back. Where'd she disappear to? To Audrey. Giant welcome back. How was your trip? And what does that mean?
She's tired of being asked.
She's already, oh, okay, you're tired of being asked. I'll ask you at some point. They're still in there then. Yeah, I didn't do anything. I left all your papers because I told you guys to turn it in today. Yo, one thing I don't know if we clarified, so please stop talking and listen to this. Bianca, put that away. You were told not to bring it to other classes. This homework collection is all work that happened before the grade cut. It is quarter one, right? Because 313 was back before the grade cutoff. So this is your final quarter one homework collection, and the graph that you're attaching with it, that's your final mastery for quarter one, right? If you did it, like, it's mastery. Now, you should have, and if you don't, you might want to fix it now, the lines on there, but you should also have one that wasn't a line, right? It looked like that weird U that we talked about. Parabola. There we go.
Wait, we had to draw lines.
West, the graph that we made. Remember the graph paper graph that we made with the big XY axes that went from like -10 to +10 and then -50 to +50? If it's all attached, it's okay. Any questions about what you're turning in? Like Avi just asked, does he need his name on every sheet? And I said, nah, if it's all attached, it's okay.
Have you seen the PBS documentary on the Vietnam War?
I have, but that doesn't have a whole lot to do with math.
No, you're talking about documentaries.
It definitely does.
I will say the only thing not directly math that I might put on is Benedict Cumberbatch. And
Yes.
no, I love Stranger Things, but not at school. Benedict Cumberbatch in The Imitation Game. If you've never seen The Imitation Game, I realized this morning with the other kids that I was just teaching, if we want to talk about the importance of mathematics and one of the biggest times it made a difference, back in World War I think, Alan Turing, a mathematician, invented a machine that was able to figure out figure out and decrypt the code that our enemies were sending messages in. And as soon as we were able to decrypt the code, we were able to figure out what they were planning, where they were going to be, and how we could prepare. That machine that this mathematician made won us the war. Hands down, period. There is no doubt. That machine, if you would have cracked the codes, won us the war. And it was just a mathematician. Now, a few, I think there was like a whole team, but he decided, like, I'm going to work on this until I figure it out. That sort of dedication is what I hope you end up finding in whatever you go into, whether it's math or not. Sandra?
Crap, the U.S. didn't even enter the war until 1917.
Well, that's fine that it's crap, but it's real. Like, it did happen. So it might be crap when we decided to get involved. I'm not making a political stance on when should we have entered the war. That's not what I'm getting at.
I would say the same in World War II for the invention of sonar.
Oh, yeah.
I think that invention kept us from all speaking German. Like, because if the British hadn't
Well,
held
you can
out,
still speak German if you want to.
well, I mean, you know,
I know what you mean.
like, because if the British didn't hold out, then we probably would have lost that war.
Simon?
Alan Turing also invented the Turing test and binary, I think?
And he did a lot. Yeah, he was busy.
But originally binary was basically just you pull punch, and that was it.
Yeah, cards. Literally, there were cards that the binary code was made by punching holes in cards. And you would put the card in the machine, and it would read where the holes punch.
So 0 would be no holes, and 1 would be holes. So that's how it translates.
Yep. Audrey?
About what we're watching on Netflix?
Well, we'll never get there at this rate, but yeah, okay.
Well, never mind then.
Well, we only have like 3 problems to do, but we keep asking questions.
We're interesting people.
All right. Mr. Wallace has a date planned. Right? And Mr. Wallace wants to impress said date. So he is planning a fancy dinner. Now, he's going to go to this fancy dinner. He's going to buy the dinner. And when the waiter or waitress brings you your bill, who can explain what you got to think about when that bill shows up? Like,
You have to think about how much you're going to tip the waitress or waiter.
and this, just especially because Audrey just got back, I will get on a soapbox and say, is an American thing. And it's annoying. Because we don't pay our wait staff, like waitresses and waiters, we don't pay them enough. So what Americans have decided to do is, since we know they get paid crap and their job is hard, we give them extra money, right? Tipping is totally by choice, but it's customary. It is a societal custom that at certain restaurants, you tip at like service restaurants. So we're going to help Mr. Wallace figure out his tip amounts and prepare for dinner so he doesn't have to shamefully pull out his cell phone calculator and pull up the tip calculator, which is a thing that every phone has, and you type in the amount of your bill and the amount you want to tip, and it spits out, here, you tip this much. Now, there's actually a better strategy than that. Make the math easy, right, which we're going to talk about. So, fancy dinner. Who's got an idea where the low end of what your bill might end up being? By the way, go ahead and sketch this. I don't have this in the... I do have this. Yeah.
Yeah, it is.
It's on the yellow sheet.
I remember that.
No, actually, this is on today's yellow sheet.
Oh,
Yeah, this is on today's yellow sheet.
Magic.
Wow, some people didn't follow directions. Simon?
Busy. From like $60, $200.
Where are you?
Well,
$200.
$200 is like California.
Steak and wine. Caviar. The molten lava cake. You bought everything. Sorry, go ahead.
Yeah, but so I went to a place in California, or a place in Florida, the California Grill. It's in Disney and it's super fancy.
Okay, well that's a really fancy dinner if we're talking about that. But I agree, they can get pricey. Now we on our table, 1, 2, 3, 4. I think there's like 8 boxes here. Let's talk locally and let's talk maybe you guys. Liam, what do you think a fancy dinner might cost? Like,
Well, one time I went to Dewey's and I spent $106 of my mom's dollars with the babysitter. So I was in trouble for that. But sure, $100 at Dewey's. Done that before.
yeah. So I'm gonna scale that back a tiny bit and say, as an adult who goes out to dinner, like maybe not fancy, but we go to dinner, like 50. It's probably the low end of like what you might be spending for 2 people. And you could get away with spending less than that, but depending on where you're at. So let's go ahead and say like 50 is on the low end. And like, we might do like 60. Or actually, we could probably skip a little bit if we wanted. We could go ahead and jump right to like 80, 100.
1,000.
Well, I'm not going to spend $1,000 on dinner. Yeah, maybe let's just go ahead and jump this up by 20s just to get a good range. And then if you really think that you might spend $200, like Simon ordering the whole menu, he's like, the left side, just give me all of that. I want to do that sometime though. Does anyone ever watch, and this it's not really appropriate for middle schoolers necessarily, anyone ever watch Bar Rescue?
Yep.
So John Tapper's this restaurateur that goes and like fixes people's restaurants. And he always, I forget where I was going with this, but there's so much on that show that I just watch and shake my head at. And people that don't know how to do basic
No,
math.
he walked in and he ordered half
Oh,
of the menu.
yeah. So he will literally walk in and just be like, give me that, 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 and like one of those too. And then people are just like, what? And they take it back to the kitchen. And the kitchen's like, what's going on? We got 20 things at once? I kind of want to do that sometime. Like, the left side of the menu, give me all of that. So this is great, what his bill might cost. Hang on to it for just a second. But the tip is kind of determined, like the tip amount is determined by how much you spend. So we're trying to figure out in dollars, that is going to base back off of what percent are you leaving. And this really is regional. So if you're out in California, somewhere else, this, you may be tipping 20, 25%, something like that. I normally go for 20, also because it makes the math easy. But for right now, we're going to work 15%. So how do we do 15% of 50? What math are we going to do, Alex?
It's going to multiply 50 by 0.15.
Yeah, so go ahead and somewhere, oh, that's the highlighter. You're not going to be able to see that. 0.15 times 50. Now, but Alex told me to do it to 50. Now, wait a minute. Wait. What would 1%, 100 of 50? Oh?
That would be 0.01, not 0.1.
I know, but I just said 1%. I'm not talking in decimals.
Of what? 50.
Of 50, what is 1% of 50?
And also, I want to say, what's that number at the very end? Can we just...
200. I said it as I wrote it. 200. 180. We're going up by 20s, man. You can make this
50
guess.
cents.
You know that I'm getting used to my board. So, Logan, we're spending time right now we don't need to spend.
50
Right? Do you have a
cents.
pointed question? And or you could have asked Ike or Josh, like, what's that number? Do you have a question you really need my help with? Okay. I would ask you to start asking your peers those things that you don't really need to ask me. Alex?
1% of 50 would be 0.5.
Yeah, if we think about 1%, this is a nice strategy that we could use. So that's really 50 cents, right? If we're talking money. So to get 15%, multiply that by 15. Well, really, that's a half. What's half of 15? 7.5. This comes out to be $7.50. Now, we'll say that point is kind of on its own, because then we start at 20 and start jumping by, or sorry, at 60 and jump by 20s. So you could draw a little squiggly here or something. After that, our pattern stays consistent. We just started with a not consistent pattern, and I wanted to get to an even number. Even numbers tend to be easier to work with. So now Simon shouted something out that was really interesting. He said 0.15x. Why'd you say that, Simon?
Oh, because X can represent, so you guys remember those input and output tables we did with the X and the Y? So we can just take the X, which would be the dinner bill, and multiply it by 0.15 to get the amount of tip, which is the Y.
Please write in X and Y. X for your dinner bill amount, the dollars we're being charged. By the way, life hack, you don't tip on the amount including the tax. You can if you want to, but the actual way you're supposed to tip is the subtotal before tax. So what you actually bought, food, drink, all that, before you get taxed. Otherwise you're tipping extra, which is nice, but just be aware that's a little thing like a lot of adults get wrong. They look at the bottom number, which they always make big and bold, because they want you to look at that number and tip off that number because it's more.
Well, I've done the thing where I went that. I went to, forget where we went, but I was at the hospital. I was like, can I order for everyone? They were like, sure. So the waiter thought I was crazy because I knew my coach liked Coronas. So I was like, yeah, give me like 3 of those too. So
He legally can't take the order from you.
Yes, I
But
know.
yeah, the coach had to be like, yeah, no, that's me. So 60, we do the same thing except our X becomes 60. If you have a calculator, this starts to get real easy because we can just replace the number we're working with. You can like click the back arrow and get back into the problem. What's 15% of 60?
4. No, never mind.
Wait,
what? I'll look it up. 4.
15%, 0. Josh? 9. And then we're going to start to see a consistent pattern. What's 15% of 80? Yeah, 12. Ooh. So then what pattern, if this is going to stay consistent, can we predict what this will be? 15. Oh, that makes sense. How much are we adding each time we go up by $20 bill? We're adding 3, right? So 8, that's
$30 for $200, which means 130 days. $30 for a tip.
21. My best friend.
No, don't do this again. It hurts my brain.
So Simon already told us how we could formalize this rule, and so we could jot that down somewhere. But that rule's really nice when we work with actual numbers, right? Your dinner isn't going to come out to be a perfect $60. Actually, when it does, I always like say something about it. I'm like, this is really cool. It's not. It's just happenstance, right? It's a 1% chance that you'll land on 0, 0, right? Like 1% because this. Yeah, but then it still wouldn't necessarily. Okay, Logan, sorry, you had your hand up for a minute.
Okay, I'm just gonna say, you said that there's tax
On food, yeah.
Wait, I thought you didn't get tax on food.
So at a restaurant, you are taxed because you're eating there. You're eating at a place. Grocery stores do not charge tax on necessity items. So there's a whole, you can look this up. Like if you're interested in it, look up like what is taxed in Ohio or what isn't taxed in Ohio. There's a whole, like there's law about what's taxable and what's not.
Also, if you said about like calling out like that perfect, like when it's a perfect number,
Yeah.
once our thing was like $120 and our order number was 120 something.
That's so weird. Yeah, I love when I normally take pictures of receipts and things like that happen. I took a screenshot last night. Did you realize that the temperature yesterday had a swing that was 40 degrees? It went from 90 down to 50 last
It
night.
went down to freezing. It was 50.
But I digress. So in the real world, hey, I'm going to try to speed up because I got some eyes looking at me like, hey, why are we going so slow? In the real world, your amounts are not nice, right? So 52.48, if we could do 15% of that. But what else could we do to make this easier to work with? If I'm trying to train you to make your life easier, make your math easier, Alex, round. So all we need to start doing is saying, okay, well, if it's 52.48, I could really say it's like 50 or 55. If I want to be nice, I could say it's 55. Excuse me, if I don't care as much, I could say it's 50. Or I could do the math as if it was 50 and then just add on a little bit. Right? Just make your math easy.
Make it $10.
So this comes down to the math vocab that Simon brought back up for us, the independent and dependent variable. So the tip depends on what? Yeah, the amount of your bill, right? The tip depends on your bill. So if we wanted to create like a graph of this, and we were going to go like XY axes this. Right now, you don't have to right now, but this is an example to help you with your homework. Actually, I would advise that you should do this. It's just a really good help for the vocab that we're writing down. The x-axis is our independent. Now, you don't necessarily, you have more space than I do, so you could write elsewhere.
Write IB.
Now, I would write the word out because you'll forget it, like next week when you're looking at it.
No,
So
mine's
X
teaching us IB and EB.
is your independent. Y is dependent. Like you are dependent on your parents.
I'm strong.
If you're not, I have a phone call to make because Job and Family Services would want to know. And Simon, hold on just a second, told us that our rule is y equals 0.15 times x. That's your homework. Yeah, that's in your actual practice work.
That's notes right here. Look.
Oh, yeah, but this we're going to do this for the actual math problem. So this is great that you have it as reference, but we're actually going to put stuff on this one. You know what I mean? So you should have had out graph paper just because we always do. And you can continue from previous days, right? Like I encourage you, your notes can continue from previous days. If I make this table, so here's the part that goes on this box. If I know that I'm on a budget and I say that my max dinner cost is going to be $100.
Whoa, that's still a lot.
Yeah, I know. I spent more than that on Sunday, and I was sad. We went out to lunch, and I spent more than $100.
Lunch?
I paid for our friend who was doing a cancer fundraiser that day, and it happens. We eat chips and salsa and cheese. Well, the chips don't cost anything, but the queso. We went to Chewy's. I've never been there before. Since I'd never been there before, I ordered something nice. So yeah.
I
It
tried
happens.
at Chipotle guacamole in their pot of salsa.
God, guac is expensive. It was like $8 for a bowl of guac.
Really
It's a big
good.
bowl. What would my y-axis go up to? I was hoping that you would be thinking about that while I was small talking, because I knew some of you had to catch up and make their graph. Charlie? 15, because we know that 15% of 100 would be $15. And then, life hack. Again, make your life easy. If you spent $0, what do you tip?
0.
0, so there's a point here. There's a point out here at 15. Well, actually, sorry, it's 115 because it's the x and then the y. Right, so that point is 115. And now what we can do, easy peasy, make a straight line. So now, any amount that we get charged, we can come to this graph, find that dollar amount on your graph, go up until you hit your line, and from here go over, and that will tell you your
That's so
tip. So now any amount we can use this table for. And honestly, if we go up to 100, any amount over that we could work with as being something doubled. Right? So like if I wanted to talk about up to 200, we already know 200 would be 30. Right? 230 and we could deal with it. Or you could just compute it. Really, if you have a calculator, you could compute those values. Any questions on creating a graph and knowing that x is always independent? Y is always dependent. These never change. Now, sometimes instead of y, they'll start to use function notation, and they will call it, instead of saying y, they actually call it f of x. All that means is a function that's using x. So you could actually do f of z, f of k, f of, it's just whatever variable you're plugging into the function.
6.6.
So you would then say f of x equals 0.15x, and that means the same thing.
I should have read this off.
Yes. Well, is it relevant?
No.
Then no.
Okay.
Because we're trying to get to doing your homework and having some free time. So when we start to have these situations, we can spot, like, wait a minute. So look at this table. I'm not even asking you to like write anything. Look at this table and tell me which one of these things is not like the other.
Oh my god.
Like, I'll stop as soon as we can find the point that doesn't fit. No, actually, I'm going to give you 30 seconds because I want to let everyone think.
Oh yeah!
Oh god. Destroy Mr. Henson.
What is this?
It's in Sesame Street. Come on.
No, he like Franklin the Turtle and Paw Patrol.
All right. So, Henry, since you want to destroy Mr. Henson, which one of these things is not like the other?
4 negative 2.
4 negative 2. Why do you say that?
Why do you say that?
All of the others subtract 4, that subtracts 6.
So Henry's saying if I compare the y to the x, this is minus 4 to get there. This is minus 4 to get there, 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 and this one isn't. So what should this be? Charlie? 0. So that would actually be a 0, and our rule would be y equals x minus 4. Make sense?
Don't get that song stuck in my head.
Final situation. And I'm not even going to make us do this if we're comfortable with it. We can just do it together. Like, you don't have to do it on your paper or anything like that. Half of x, then add 6. Guys, the one thing you got to be really careful with here, order of operations matters. Right? Always. There's never going to be a time I say order of operations is irrelevant. Right? That like, makes me feel dirty. So you have to half the x first. I know, especially working with negatives, you're like, oh, can I just add the 6 first? That'll make things easier. No, you half the x first. So half the x, negative 2, add 6, positive 4. Half the x, negative 1. That's kind of gross. Careful with this addition. Add 6.
5.5.
Ooh, here's the Common Core way of thinking that, like, I say that as a good thing, but we didn't used to think like this. If I'm at negative 1.5, how far is it to get back to here? 1.5. How much do I have left moving forward? 4.5. Because 1.5 plus 4.5 makes 6. Right? Break up your 6 to get across that 0. So we will end up here at 4.5.
Why did it give us an icky number?
Now wait. The x's, negative 3, negative 2, negative 1, 0, 1, 2. Ooh, these are really nice x's.
6.
So this
It's adding
is showing our slope of 1/2 each time. So what should this be?
5.5.
This? Yeah. So now that we understand slope, this becomes super easy to deal with
How did they do that? What is this? What happened to
because
that?
it has a consistent. I know. It's bad.
Viewpoint S.
All right, you have the rest of our time together to work on anything you need to work on. Who what? I will not do this in the middle of class anymore, though, right? Now that I'm done with my teaching. Whoa, this is a sexist note. It says life is hard, so is math, and children, especially boys. Deal with it. Nothing is easy. Your friend 21. You know what? I've encountered some girls. I think I've encountered some girls that are just as much of a handful.
I don't think it's I think we have
Wait. We can do anything as long as it's academic.